All right. So we're talking about competitive balance, and we'll kind of keep moving with that. And we'll focus on initially in the class, kind of reverse order draft. We'll look at a paper that I kind of have a link to in the slides. I might jump around a little bit today, kind of reorder the slides accordingly. But starting out, we'll think about kind of a reverse order drafts, right? We're worried about making sure that the best teams in our league, the lowest quality teams in our league, we're getting kind of the win gap to be lower, right? So one thing that we could do is if we rank teams, right, who gets kind of the rights to the next best player coming out of whatever the minor league is, or whether or not that's high school, college, depending on the sport, what level they can kind of recruit from, right? We'll rank them based off the previous season. And then whoever has the highest number of wins gets to choose first. We would think choosing a higher quality player first. And whoever has the lowest number of wins is going to get the last pick. Right? So how might this improve competitive balance? Well, it's going to take my lower quality teams, and it's going to ensure they get the rights to the highest quality incoming players. Right? So these reverse order drafts, right? The reason why they do that is to try to improve our lower quality team. And that kind of makes sense. They talk about teams will tank for these picks, right? The whole goal is like, if I take a team that's low quality, hopefully I'm giving them a better chance to improve their expected number of wins or higher quality. I'm also not giving those same opportunities to my high quality teams. So kind of bringing that, distance in the number of expected wins between them closer together, right? So the goal is to raise kind of bad teams and have more parity in the league, right? That's the whole point of this reverse order draft. But like, what can go wrong, right? So it exists in every single league. But we could think about which one of these we can think about it in two ways: competitive balance currently and competitive balance in the future, right? So within this current season, right, how could this reverse order draft actually make competitive balance worse? So the season is just now starting, right? The old draft is done. We're just thinking about kind of starting from this season on. How could the reverse order draft that's upcoming impact the current season that's going on?
Bad teams not trying to win.
Yeah, so it provides incentives for bad teams to make sure they lose even more, right? Because now I want to know what's the probability I get that highest pick, right? Well, the probability is going to be guaranteed if I can get the lowest number of wins in some of these leagues. There's a caveat in the NBA we'll talk about here in a second. But for most of these leagues, you think about if it's just the reverse order aspect of it, the current season, you might actually see initially this decrease in competitive balance. And then you're hoping that the following season, those teams that tanked or lost win, or guaranteed that draft pick, improve their wins and improves competitive balance in the future, right? So it's hard to kind of eliminate that year to year. You might help improve competitive balance by guaranteeing some of these high quality incoming players getting low quality teams, but you're also going to create a little bit of competitive balance, like worsening, right? Because there's an added incentive to lose to make sure you get that pick. Right? Good teams are largely unaffected. It's really those bad teams, right, that want to guarantee. If I'm, going to make it to the playoffs, well, I don't have the incentive to try to get the best draft pick because I don't want to just lose and then not be able to make it to the playoffs. It's really only your teams that don't think they have a chance that are then going to kind of exhibit that, fall victim to that incentive, right? So what part of the season would you expect a reverse order draft to have more of an impact on? Beginning, middle, end of the season? Yeah, right. So you're thinking there's probably a lot more uncertainty at the beginning of the season about what my possible number of wins is going to be, or what my likelihood of getting these lower draft picks is going to be. So even if I don't think I'm going to be, I might think I'm middle of the road going into the season. So I may not, halfway through the season, I see, well, I'm at the bottom of the league. So that second half, I'm going to make sure I stay at the bottom, right? Because I know it's very unlikely that I can get up to the playoffs. So I might as well take advantage. If I don't make it to the playoffs and get that additional revenue, I want to ensure I'm getting the better quality or higher quality draft pick. So you can think about for a second, taking out the fact that the NBA, if you have any knowledge about it, has a slightly different reverse draft order. Let's just assume they all have the same. Which one of these might we expect to have kind of the biggest tanking problem and why? So this gets to start introducing some ideas we've touched on before. There might be a little bit different.
Basketball,
Yeah, so why would you think basketball?
because if you draft like a generational talent, they can take you to a playoff or a championship by themselves.
So yeah, what you're really saying there is, you can think about it as there's going to be a couple things that matter, right? So if you're thinking about what we call the marginal productivity of labor, right? Well, in the context of what we're thinking about with players, it's really our product is the number of wins, right? And we said, we have this diminishing marginal wins coming from each player, marginal wins from labor. So we know it's declining, but we can think about in the NBA, any one player likely has a lot more influence. There's only 5 players in the court at a time, as opposed to, the higher number in the other sports. And if we look at, you can actually estimate this way, we do see that there is kind of on average, right? Your average player in the NBA adds a higher number of additional wins compared to any other league, right? And that those high quality players in the NBA definitely have a higher number of additional wins than, you can compare it really to any sport, right? Now, there might be differences in the NFL with the exception to one thing, which is what? Why might the reverse draft order possibly matter more in the end? So you got the one trait, which is just having fewer players is going to increase the marginal wins that are coming from each player. But why might the NFL actually, why could you argue that the NFL's is higher? So any one player, think about the different positions. What's one position that might have?
I was gonna say if they draft like a quarterback.
Yeah, so you can think about, we've got different positions. In basketball, you do have different positions, but generally, like every position has kind of the same ability to add a high number of wins, right? You can get really productive or a center that adds a high number of additional wins. You can get point guards. I don't think you would probably find anyone that would argue the number of additional wins that a cornerback adds, right, is the same as a quarterback, right? Now, it's going to be, depending on the year, like, maybe there is this just revolutionary cornerback that could, but for the most part, when we look at these estimated number of additional wins, we're thinking probably there, the reason why it could be different in the NFL is because that number of additional wins added from quarterback is really high. But if I don't need a quarterback, well, then getting that top pick isn't as influential, right? Because I know that the number of additional wins that whatever other position is going to add isn't near as much. So could we have some positional differences of why this draft might matter more for some leagues? You can imagine this changes year to year, right? So a very real kind of time, present day example of this, like at least from my knowledge, the last couple of years in the NBA, there hasn't been a lot of talk about tanking for one specific player. When they know that there's a player who's about to come into this next draft, I forget his name, he's like 7'4" and skinny as a beanpole, but like he's supposed to be really good. And then there is a discussion of now we know that there's this really high marginal number of wins that are going to come from that first draft pick, right? Same idea with quarterbacks. You have years where there's not really a talent that anyone thinks is going to be that good at the next level. You don't see teams worried as much about getting that best draft pick. But if you know that you've got, what's the kid's name? Arch Manning, right? Like the next Manning that's about to come into the league. You might want to make sure you have a really good draft pick that year if you need a quarterback, right? Because you think he's going to be this really high quality quarterback. So it varies from year to year as well, which one of these drafts would have more of an incentive to tank. But this is one of those things, it's a complex kind of problem we can talk about through all of them. So fewer number of players probably matters. What's another way we could think about, not just the top draft pick, but let's say like in the top 10. So there is always probably going to be an incentive to be the lowest number of wins because you get that highest quality draft pick, right? And any year, there's probably going to be a high quality player there. But we think about like picks 2 through 10, right? Well, if I can still get really influential players, like maybe in the NBA, like I can draft someone at 3 or 4 and they could end up being, one of the best players in the league. So they could have a high number of additional wins. So in that picks from 2 to 10, what's another thing that might make tanking more or less attractive? It's kind of a weird one. So it's not just about, if you're thinking about not just the top draft pick, it's kind of like how steep are marginal wins coming from labor is decreasing, right? Because if it's a real steep kind of drop off, like my diminishing marginal number of wins is really diminishing, like if I look from the best to the second best to the third best to the fourth best player, well, if that's a sharp decline, then there's not near as much an incentive to kind of lose unless I know that I can lose enough to get that top pick, right? But if it's a relatively kind of flat marginal number, marginal wins from labor curve, then I would see an increase in the tanking incentive, right? Because now, if I know that picks 1 through 10, right, this marginal wins coming from labor is declining relatively slowly, that the top pick in the draft might add the same number of additional wins, or obviously a little bit higher, but like really close to the same as the 10th pick. Well, now, even if I'm on the verge of making the playoffs, or I'm in the middle of the pack, I might try to just get down to that bottom third, right? I might want to be that 10th best team if I know that I could still get a really high quality pick there, right? Or a really good player. So if we have kind of a steeper decline in our marginal wins, like the quality distribution of incoming players, we might see that makes it a little bit less incentivized to tank. So I would say, like in the NBA, you do kind of see this desire to tank for these top 3 draft picks. You don't really see people in the middle all of a sudden switch trying to lose, to get the 10th or the 8th or the 9th. Whereas you might see that in other sports. So there's all these things working on at the same time, but we can think about how all of them would kind of impact that incentive.
Would it change since the NBA is a lottery, like a middle of the pack, maybe?
Yeah, so
losing to get the.
So what I started off with is I said, I know if you have some knowledge, the NBA is a little different. Let's assume that it's not for a second, because you're right. If we think about what the NBA is doing, we can kind of model this here in a second. So let me see. Keep going here. There we go. So what might I do to prevent tanking? I create a lottery system where, just because I had the lowest number of wins doesn't mean I'm guaranteed that top pick. It means I'm going to have a higher probability, right? So it's still, you're not going to eliminate the tanking problem, because now all we're doing is, before, you could think about it as, if I have the lowest number of wins, the benefit is going to be whatever that marginal benefit is to me of that first pick, or the number of additional wins that first pick would add, right? If I then go to the NBA and I have the lowest number of wins, but I now have this lottery system, right? Well, what's that going to do? It's going to take it so I have an expectation of the marginal benefit of whatever pick I get. This is going to be a much more complicated thing to determine, because now this is going to be the probability I get the first pick times the marginal benefit I get from that first pick. And then add to that the probability I get instead the second pick, because that's not guaranteed anymore, right? I don't know how if they still do it this way. They used to like draw balls out of like this huge like spinning thing, how like bingo or whatever it is. However they determine now, maybe they just use random generating number on a computer. All right. Regardless, I'm not guaranteed to get that first pick. So I have to build this instead all the way, pick 1 through wherever the lottery stops at, right? So it becomes a much longer kind of calculation, because I know if I get the lowest number of wins, I'm not guaranteed that best player, right? In fact, I take whatever value that first player would have, but then multiply by to probably actually get that top pick, right? And then kind of move on down the road. Does that make sense? What we're doing, the expectations there? When you think about this is like as simple as in a weird way, what you're doing here. Just talked this last week. So in 221, when we talked about discrete random variables, we can think about what we're doing is I've got all these different outcomes for X. So this is like, I get the first pick, I get the second pick, so on and so forth. I then have, okay, what's the probability that I see X, right? And then it was like, I'd figure out what this is. I can't remember what the numbers are in the NBA, but right, you have the highest probability of getting the first pick if you have the lowest number of wins. And then all we're really doing is going through and finding a weighted average. But it's an easy weighted average because we know those probabilities should add up to 1, right? The probability I get whatever the first pick and the last pick has, I get one of them. So I add all those probabilities up, they half that up to 1. So it just becomes more complicated, right? But we'll notice it definitely does decrease the incentive, because before this was the incentive, whatever the marginal benefit or marginal number of wins that top player is adding. Now it's going to be that, but times something lower than 1. So it's definitely going to decrease that marginal benefit. And we know that even all these other things, probably give the second pick, because we have declining marginal benefit of later marginal wins from our labor, we know that this marginal benefit is less than the first pick. So by introducing this lottery system, we automatically decrease the incentive. Now the incentive still exists, right? This is still there. It's just multiplied by something less than 1, so it's not as great as it was before. Any questions on that idea? We'll start building in a little bit more of these expectations. At least I'll be showing you examples of them, because like that's really what a lot more of it looks like in application, is that, the same idea. We don't know exactly what demand is. We're actually making a projection or what the expected demand is. Same kind of idea here. What's our expected draft pick? Okay. All right. So go back here. Oops. And then we've, the other thing that really matters with these reverse drafts is that teams can correctly identify talent, right? So we're relying on teams that if they do get, we're doing this reverse draft order, even without the lottery, we're guaranteeing that the person get the lowest wins gets the top pick. That really only works at improving parity if that team that gets the top pick can figure out who the best quality player is in that draft. If teams are not good at doing this, right, they're way off, then the draft's not going to matter, right? You take a player with that top pick and they end up never even starting a game for you. Well, then the reverse order draft didn't help us improve parity at all. Right? So we also are relying not only on this diminishing marginal kind of returns to labor, or the diminishing marginal number of wins, we're also relying on teams can identify what that is with the players, right? They're correctly identifying the number of additional wins each player would add. And we already talked about, it works better. I shouldn't say it's required, but it works better when we have a faster decline in the marginal number of wins, because then that top draft pick is really valuable, right? So this is the paper I wanted to look at. It's related to draft order and valuation. I think I kind of walked through it here, but I'll explain and kind of use the dot cam to give you a little bit better idea. So that link, if you wanted to pull it up, if you're interested, you can copy and paste it. And we'll scroll down to page 1486. Don't worry, it doesn't start at 1, but 1486 is the top of where we're going to first start looking at. So the whole question of this paper is they started to think about what are the real value of draft picks. Like you see trades happening all the time, not with players, but teams include draft picks, right? And so can we figure out which draft picks are the most valuable to have? Because if I can figure out which draft picks are the most valuable to have, I'm going to want to make sure, when I'm trading that I obtain those. Now, you might think, well, yeah, the best ones are always going to be the top draft picks, right? Well, not necessarily. They're going to have the highest number of additional wins they might add or the highest marginal benefit, but they're going to come at a high cost, right? So we want to figure out, like, yeah, that top draft pick is great, but I also know that it's going to come at a high cost. I have to pay that player more, right? If I want to trade for it, I'm going to have to give up more asset. And so maybe the costs are changing as I move down the draft order differently than the number of additional wins the players are adding changes, right? So my marginal benefit, my marginal cost might be declining at different rates, right? And so they have a kind of interesting way of getting this, and I'll break down kind of what their equations are to make it a little bit more simple. So the first one, what they're going to do is say, okay, look, we haven't necessarily talked about this yet, so I'll do a very simple thing before we get to their specific case. Let's say I have, well, I'll use it. Let's say, I do number of wins and the number of additional points a player scores. Okay. So maybe I'm saying, okay, if the points scored by my top player, right, goes up by 1, right, per game, what's the increase in the expected number of wins? This is a toy example here. So I run this regression. I don't know. I see something like this, right? So I'm thinking about there, if the best player in my team scores one additional point, right? 1 unit increase in X, the number of additional wins I would expect is 1.3. Right? I don't know if these numbers make any sense, but you kind of get the idea of once I obtain these estimates, what I could then do is say, okay, look, how many wins would I predict? So we usually write that kind of with a hat over it. So Y, right, our dependent variable, which is wins. If we want the predicted value of Y, we usually write that as Y hat. So number of wins hat here. Right? So all I would do is say, okay, what's the expected number of wins for a team where their top player scores 20 points? Well, all I do, plug in my intercept value of 15, add in that top player's expected number of points, and I get my predicted is what? 26, 30, 41, if I'm doing math in my head correct here. I might not be. But that's the general idea of what we're doing. We'll run this regression, we'll obtain these coefficient estimates, and then to make our predictions, it's just a matter of, okay, plug in those values that I found for my intercept and my slope, and then I can make a prediction for different teams that have a top player that scores a different number of points. Right? So we can use these coefficients to make predictions. So what this paper does is say, okay, look, let's look at compensation or salary of the player, right? They then say, okay, we need this intercept. They're then going to include a bunch of different controls for what that player's performance was. So they might do points per game, rebounds per game, go through all the statistics. Like maybe they use PER, player efficiency rate. I can't remember, we'll see exactly what they use, but they're using all these different metrics for player performance to say, how do all these things impact their salary, right? So once we have this regression, we have these estimates, I could go through every single player and figure out, okay, what's this player's expected compensation? And so instead of doing this player by player, we can also think about doing this. Sorry, we'll leave it at that for right now. So I could, for a player, come up with what their expected compensation should be, okay? After that, any questions, by the way, on that so far? Is that kind of clear? Kind of remember making those predictions a little bit from 221. So I had a real simple example here. You can imagine if I've got 30 control variables, it just becomes a longer equation, right? So go back and look at, so they've got kind of those results, right? And they included like different things like what year they were in, how many starts the player had. They then looked at, we'll skip down here a little bit, is this idea of a surplus value. Okay. So once I know what that player's predicted compensation should be, we're going to define the surplus here as whatever that expected kind of salary was, right? Or expected performance value minus the actual compensation C, right? So we can think about here, what they're going to do is they're going to run this regression, use these coefficients to, for every player, use that player's statistics and come up with, you want to think about it this way, like a predicted compensation amount, right? We'll then subtract what their actual compensation was, and this is what they're kind of calling that S, or that surplus value, right? So this is what I should have been predicted to pay the player. Here's what I was actually paying them, right? So when this is positive, that means that I'm getting, for this player, I would expect that I have to pay him this much. I'm only paying him this much. So that difference is my surplus. You can imagine, like, if I ever get a situation where the actual compensation is greater than the prediction, well, that means I've got negative surplus, right? I'm paying this player more than what I'm expecting I should have to. Okay. So once we have this surplus value, they do this kind of cool thing where they've got, okay, I've got these players and I've calculated what their surplus value is. I'm then going to say, okay, look, were they, and I might get this wrong, but this will be the general idea. Were they taken in round 1 of the draft? Were they taken in round 2 of the draft, et cetera, et cetera? And then now these coefficients tell me if I see a player taken in that first round, here's the additional increase in surplus, or decrease it could be, but increase in surplus relative to whatever group I leave out here, probably the last round, 7th round. Okay. Now, I think what they do, we'll go back and look here, but I believe they break this down even further, which is, I don't want to know the value of a first round pick. I want to know the value of the first pick, and then the value of the second pick, and the third, and the fourth, and the fifth, and kind of go all the way down. Then when they run this regression, they essentially will have these coefficients that tell you, having this first pick, here's the expected kind of surplus that I would expect, right? So I could then rank these picks based off the surplus. So we'll go back and look, double check that's what they did, because I'm pretty sure. So yeah, so they took this surplus measure where they took their prediction minus the actual compensation. We'll then kind of come down here, and you can see once they ran those regressions, they plotted out the expected surplus for every single pick. So originally they did something I didn't show you earlier, which is they just kind of estimated the value of each pick. So to give you an idea about what that is, just to kind of have a complete comprehensive picture here. They were kind of looking at some performance metric, and there, if I don't know what they used, probably what they should have used is like a win share, or some kind of like composite measure there of player performance. And then they said, okay, look, what's the expected kind of player performance, or a number of additional wins would be like a perfect thing. That's why I said win share is probably a good one, where you could see how many win shares would be added from having that from a first pick. And then how many win shares were added from a player if they were the second pick in the draft. Go through and do that. Now you have these coefficients. You could just graph those out. Pick 1, pick 2, pick 3, plot kind of what their expected performance was, or the expected number of additional wins there. So you can kind of see that here. That makes sense. This could, if you go back up at another table, they estimated this line because, and they basically found like, oh yeah, it's diminishing marginal returns to labor, right? The top pick has the highest number of additional marginal wins, and it kind of declines. Right? What's interesting is when you look at the surplus value though, for these different picks, and we then, right, where we have the dependent variable surplus, and we plotted these coefficients, what we actually see is that the surplus initially is actually increasing. So that the expected surplus from having the second, third, fourth, fifth pick is actually higher than having the first pick. And that's really, it must be a byproduct of the fact that the costs are really rapidly declining. Yes, the marginal wins that these players are adding is declining as well, but the cost of that top draft pick is going to be so much higher than even the second. Right? And so the actual valuable picks to have would be the ones up here. We're thinking about including both costs and benefits. It's kind of interesting. It looks like it caps off right about the end of the first round. Well, then we see it kind of follows more what we would expect. It's just kind of constantly declining, right? But for that initial first round, the actual surplus value is increasing for having like a lower pick, which is, I think, maybe counterintuitive or something we wouldn't expect. So, and this is, I think, specific to the NFL. Let me make sure that, is this the NFL or the NBA? No, it's NFL, because they were talking about Pro Bowls. Yeah, and different, they kind of did some stuff with different positions. So like you could break this down probably differently and figure out like, if I did this only for quarterbacks, what's the value of each pick, and then so on and so forth.
I was just gonna say, do you think that's because teams are like reaching for a quarterback or reaching for?
So my guess would be there's some of that going on, but I would really only expect that if you saw like a real quick thing, right? This kind of has this nice increase in surplus. We look at it, goes all the way to basically the end of the first round. So I think it's probably driven more by the fact that those higher up picks are just going to command a higher salary, right? That compensation, their actual compensation, is going to be so much higher. And if we're defining surplus as, well, their predicted compensation minus the actual, then it's going to be more likely we even see negative values at the top. Well, I don't think we see negative values, but right, it's going to decrease that surplus value at the top. You know, if I take a pick someone halfway through the first round, I'm not gonna have to pay them near as much. Their actual compensation is gonna be low. However, their predicted compensation, they might still be a really high quality player. It's just they weren't drafted in the top 10. They weren't one of the first 3 picks. And so I can get away with paying them a lot less. Is that
Okay. Questions or anything there? So I wanted to use this paper a little bit because it's about the reverse order draft and kind of shows like, actually, maybe it's not like the best. Like this is actually a good thing. If I'm the NFL, I look at this and say, well, I don't have to worry as much about my reverse order draft creating an incentive to tank, right? Because if the expected surplus value is higher than some of those later picks, there's all bets are off, right? I mean, why would I want to get the top pick if I know the surplus value is lower? So it kind of reduces that incentive to tank if we have something like this going on. I haven't seen anybody do a similar kind of estimate for like the NBA or Major League Baseball or NHL, but you could do a very similar thing as long as all we needed was some player statistics, right? We needed some information on what round they were drafted, and we needed salary data. But as long as you have that for any league, you could do a very similar thing and see in these other drafts, do we actually see kind of this increase initially in surplus for positions? My guess is it might vary a lot across leagues. So for some of the things we already mentioned, right? The NFL might not have as steep of a decline in player quality, right, or marginal wins as maybe the NBA or something like that. So it'd be interesting to see it kind of run, but I've never seen anyone do it. So I haven't taken the time, but yeah.
Do you think that the MLBs could be like flatter because of how many rounds there are?
So probably the number of rounds wouldn't matter as much as the number of rounds probably wouldn't matter as much as the fact that in Major League Baseball, especially if you're looking outside the position of pitcher and even one pitcher, I think the marginal wins, we looked at some studies that estimate the number of additional wins players add or win shares way lower in MLB, right? First of all, you have more players in the game, but like if you're a position pitcher, you're only playing 1/5 of the games. If you're a position player, it doesn't matter how good you are if no one else is getting on base, like you're probably not adding wins, right? Your performance might be really good, but you're not bringing in additional wins probably. So my guess is for the MLB is, and also I would imagine it has a flatter decline. Like I think that the drop off is probably lower than the other one. And this is just, I don't know this for sure. This is what I would guess. I would guess you'd probably see the surplus value. It would kind of smooth that bump out. But once you get to like these later rounds, you're going to get this thing in Major League Baseball, probably where like it really looks like this, like because the surplus value in those late rounds, like I don't even remember how many rounds they have, but it's like, but you get into the double digits. So you're like, what's the difference? Yeah, what's the difference between round 20 and 30? I don't know. We're so far down this marginal wins distribution, right? We're really looking at similar players. So I would expect it probably does flatten it out there in the first round just because that number of additional wins added isn't as high. So like in the NFL, for these picks in the end of the first round, they still had a really high number of additional wins they're at. Major League Baseball, I would just expect that there's like a lower level. I don't know. I haven't went through this, but yeah, it was really I also wanted to use it just to kind of point out and show the usefulness of once we obtain these coefficient estimates, we can use them to make predictions, right? And here they just did multiple levels, like they made predictions and then used those in a separate regression, which kind of has some interesting implications. Questions on this before we go back to the slides? Okay. So I want to, I think as we go through the semester, I'll probably bring up more papers, not just on Fridays, and we kind of work through them. So we're getting an idea about how we think about running regressions, what variables we would want as our dependent and independent variable. All right, so this was kind of related to what they were doing. They were regressing draft position for surplus. We found, summarize their findings. We already looked at the graphs, right? So you don't really need to kind of summary slides of what they found. That really it's decreasing after the first round. But that first round, you get this surplus increase, right? As you're looking at kind of higher, like numbered picks, actually, which lower or further back in that. So we can think about trading now these draft picks, right? They have some value, right? So we might want to trade them, right? I know that not just players are going to help teams out, but they're making projections for the future. So they might find this draft pick beneficial as well. So if I can trade these draft picks, how is this going to impact competitive balance, right? So it's kind of a weird thing, but we talked about it a little bit last week. So think about what draft picks are. Even if I win the draft lottery, not in the NBA, so we're dealing with a guarantee that I have won the lowest number of games, I'm going to get that top draft pick, right? Why might the ability to trade those draft picks not change what the reverse draft order's impacts are on competitive balance? So let's think about if a team with a top quality quarterback currently just has a bad year. I don't know. Maybe that quarterback got injured, right? Couldn't play for a lot of the year, but they're still expected to be a high quality team. But for whatever reason, they had some injuries, they end up with the lowest draft, right? Or maybe if we use the NBA example, they didn't have the lowest number, but they just somehow ended up with a draft pick, right? So for team one, you can kind of think about it as they've got this top draft pick, and we could think about what's the marginal benefit of that first pick to them, right? Or you can think about it as what's the number of additional wins that first pick is going to add. So team one is going to have, some evaluation of this, right? And let's say we've got team two, and we could think about, and actually here we'll do team one for the first draft pick, and then we'll do team two for the top draft pick. So remember, team one, we said had a high quality quarterback, right? So we're assuming that probably whatever position can add the highest number of additional wins. For the sake of this example, we'll think about this as a quarterback, right? Team one, right? If they use their first round pick, they're not going to draft a quarterback. They already had one, right? He was just injured, and so he's coming back the following year. So that first pick to team one is going to have a much lower number of additional wins because they're not going to be adding that quarterback position. They're going to be adding the best player from one of the other positions. Now, that's still going to be high, but it's likely that the first draft pick to team one, because they don't have that positional need, is going to be less than the number of additional wins that first draft pick would add for team two. So we have the property rights being that team one actually has that top draft pick. But if the value is lower to them, and you could think about this as we haven't went down this road too far, but the demand for labor, the demand for a player is really going to be the number of additional wins they add times the marginal revenue per win. Okay. So if we think about this as, not just adding the quality of the player, but how much money is that player going to add for the team? Well, team one looks at this and says, well, maybe for team one, you can kind of think about their marginal benefit or their demand for having that first pick. Maybe it's, 50 million. But then for team two, because we know that marginal wins from labor, because they need the quarterback, they can draft, if they had that first pick, they could draft the quarterback, really high marginal number of wins. Marginal number of additional wins. Maybe the value of the first pick to them is 100 million, right? Because they're getting this generation, they're getting this player who's really going to change the quality of their team. While as the second team, they're not drafting that position of quarterback, they're drafting kind of positions that don't typically influence the number of wins as much. So what's going to happen here? Team one has the pick. What do you think they're going to do? They have any idea, they have any idea that second team needs a quarterback, which is usually pretty public information, right? You can look at a team's roster and know who's going to be there. Then we end up with that invariance principle kind of taking over, where we could come up with any kind of amount in between 50 and 100 million, where both these sides are going to be okay trading this, right? So whether or not team two gives them $75 million, and that doesn't have to be cold hard cash, but that could be in players, right? But they would be willing to give them up to $100 million to get that pick. They're okay trading that pick for anything over 50. Now, it gets a little more complicated, like what is the final, right? There's some bargaining, things like that. We'll actually talk about that, I think, after the first exam.
go through some contract negotiation stuff. We'll really use that to highlight bargaining. But teams would have kind of a similar thing where they're bargaining, that we will know the range, and that's just a matter of who has the most influence, right? And it becomes a little bit more specific to the example of where exactly we would think that we would land. But we can at least see here, doesn't matter who has those top draft picks, who's always going to end up with them? The teams that value them the most. Okay. So one way in which that it might not break down, right, is this invariance principle, right? And I use the quarterbacks as the example just because that's probably the most, I don't know, would be the most relevant example, but it would take place for other teams as well, right? Like if I'm a team, once again, in the NBA, right? And I'm pretty happy, but I had a couple injuries in the last year. So I somehow ended up with the top draft pick based off the lottery system. I know there's other teams out there that maybe they had actually the lowest number of wins, but in the lottery system, they ended up not getting a top pick. Well, then what's going to happen? They're still going to really have a high value that first pick. We're going to see a lot of trading going on. Right? It's kind of intuitive, right? If I don't need that draft pick, right, it's not going to be as beneficial to me. And I know it's more beneficial to someone else. There's going to be a range of values we could agree to trade on. So this is, I think, something I want to point out. So there's a difference between large and small markets. So kind of introduce this idea. So I'm going to keep running with it. I'm making a different point, so I'll use a different color here. But if I have that, like the demand for labor coming from teams is the number of additional wins that that player adds times the additional revenue per win, right? So this is the real value to the team, right? If I then think about the demand for a small market team, let's say I've got two identical teams, right? Same quality players, like, you know, this is a bit of a thought experiment, but exactly the same quality players. So the marginal wins coming from each player for this small market team is the exact same, as the number of additional wins that that player would add to a large market team. He would add the same number of wins no matter what team they join. I guess I shouldn't gender this, right? This could be the WNBA, but we have, you know, whatever team they decide to choose, that's the one that's going to be the highest, or sorry, they're going to have the exact same marginal wins coming from labor, right? The difference is, if I think about the marginal revenue coming from wins for a small market team versus the marginal revenue coming from wins for a large market team, what I knew is probably true about the marginal revenue the large market team is facing. Yeah, we always had that marginal revenue curve was shifted higher for large market teams. So this same player, that large market team, even if the quality is constant, no matter what team they add, they would add the same number of additional wins. The large market team is always going to be willing to pay a little bit more. So when we think about these draft picks, the large market teams will always be willing to trade a little bit more, right? Give a little bit more value to these teams that have the top picks. If those teams are small market teams, they won't value as much. And they're gonna be like, well, look, we can trade this. Maybe the pick only had $50 million value to us. If we can trade it to a large market team for 75, we're better off, right? We could take that money, spend it on even more players, right? So, you know, this invariance principle really kind of helps break down that we know. Just because you're getting the top draft pick, that doesn't automatically mean that you're going to use it. Someone's going to trade for it. What's the problem? If large market teams are more likely to and willing to trade for those draft picks, they get top draft picks, add even more quality to their team. We already know they're going to be able to target a higher number of additional wins. So here, the invariance principle actually makes it so that this reverse draft doesn't really influence competitive balance at all. So what's one thing we could influence? What's not one thing we said could break this invariance principle down? So when we're doing the ticket example, I said if you were selling your ticket on StubHub and they charged you $20 for every transaction, well, that was the idea that, well, now maybe where we could have come to an agreement before, we no longer can, right? Because there's this additional cost. So if we can include some type of transaction cost, we could actually help kind of break down this fact that the large market teams would always be more likely to trade for those top draft picks. And I think they try to do similar things now, and I don't know I should have looked it up. I'm saying this off the top of my head, but there's like
compensatory picks that the NFL is giving out now. And I think it has something to do with if you're trading top quality players. Does anyone know this off the top of their head?
That happens for like higher minority coaches.
Yeah, so different things that teams do, they try to disincentivize them with like, if you do this, you're gonna have to give up a pick like to these other lower quality teams, but
I think that they've just been using them like as like punishment.
punishment right now. So, okay, so I wasn't sure on this. So what could they do with them then? So instead of punishing teams for doing bad things, if I really want to make sure that the lowest quality teams are keeping that lottery pick, I can already see here, I need to increase the cost to them this trade because they're going to benefit. Let's say, for whatever reason, instead of 100, this is 75, and the large market team will pay all the way up to 75. Okay, so I'm gaining an additional 25 million. Well, what if the league says, okay, if you trade away a top draft pick, it's going to cost you X number of dollars. Now, these numbers are a little ridiculous in this context, but right, if I set the trade that if I trade that first draft pick, the penalty is 25 million, right? Or that I have to give up other draft picks that would have a valuation of 25 million, then maybe I could prevent this invariance principle from just seeing those top picks traded to large market teams. But as of how they currently have it set, the invariance principle probably wins out. So it would be interesting. I haven't seen anyone do this, but you could prove to yourself that this is happening. If you looked at any trades that occur in the first round, I would imagine, you know, if this holds, what you would end up seeing is that like all the teams trading up are generally more likely to be from larger markets, right? So that's not just population, right? There's a lot of other factors, but whatever teams we see kind of trading up in the draft more likely means that, you know, they're probably a larger market team. Now it could also be, there's two things going on. That's only if we're holding constant player quality, right? It's possible that the small market teams, they don't have the quarterback, the large market team does. So then the marginal wins is lower for the large market team, higher for the small market, and then maybe, you know, we don't have the same thing kind of playing out. So for these small markets, even though we know the marginal revenue is lower, we can still see them hold on to their top draft picks if they have these positional needs that are going to add a high number of additional wins, right? They don't have a quarterback, or they don't have, you know, fill in the blank, you know, star, whatever position in the NBA. So, but this is I don't want to introduce kind of, there's two things driving this demand for labor. And all the demand for labor really represents to us is the value of that player to the team. How many wins are they going to bring to the team? Times how much money each one of those wins is worth. Okay.
Any questions on this? It's just kind of making sense here before you. Yeah. Okay. So I think that should cover all the points there. So we're going to skip this wages and tournament stuff. I think we'll probably just get out a little bit early today. So what we'll start with on Wednesday is we'll kind of change gears a little bit, and we'll talk about facility costs, team location decisions, benefits to the city. So we'll think about kind of, you know, maybe some negative, positive externalities. So we'll do a little bit of review of the externality market and then put it in kind of context of some specific examples. I will get up the weekly reading. I've got it between two papers. Looking at them this morning, and I still haven't decided, but within the next hour or two, I'll throw one of those up there on Canvas, and that will be the one that we go through on Friday. Okay. Any questions for me before you? So everyone was here as well. As long as I've got it pulled up, we'll kind of get full credit for today. I think I've actually got an ICO's question for Wednesday because we didn't quite get to today. Well, today, any letter kind of give you the full 10 out of 10. And I should start getting some data sets out to some of you. So look for those in your email this week. I should be kind of chipping away at that list and getting you some data. Okay. All right. We'll see you guys on Wednesday. I know it's supposed to be nice, but it'd still be nice if you showed up. So
You know the job fair.
what time? Well, if you missed, yeah. I probably just won't use that.
I don't know if you knew that.
I forgot that it was this Wednesday.
I thought it was next Wednesday. What's today's? 13.
Okay. Huh. Yeah, I thought it was later in the semester.
Wednesday, I guess.
Oh, thank you. No.
The question.
Yeah.
I only mentioned that because it's the class that I have right after this.
Yeah.